Hi, if you take retailers like Walmart or Amazon or Costco and they want to predict their overall retail sales every month. Now, if you see this retailer, they might run multiple shops or multiple outlets, and each outlet might have a different sales cycle and different sales target. Now, some might be close, some might have proximity closer to the residential area. Some might have, so in some area, the income range might be different. So, a lot of factors come into play when you need to predict sales target of overall Walmart. So, rather than thinking every store alike and then predicting it, what typically we do is we predict sales at every store level and then aggregate to predict overall like Walmart or Costco sales. Every store by itself might have its own seasonality, might have its own purchase behavior, customer patterns, and everything. Now, this is where if you see you are running multiple time series, you are for each store has its own time series of data, and you are running time series. Similarly, you are doing for thousands of store they might have, and then you are aggregating it, and this is what we call as multiple time series. Multiple time series is there across all the industry. If you take weather prediction, weathers are typically predicted at a zip code level or a particular geolocation level, right? If you take electricity demand, basically if you are doing an electricity demand for a state like New York City or Arizona, the demand might vary depending on that is an residential area or a commercial area. There are multiple factors that comes into play. So what you do is rather than just running demand across the entire state, you may break it up into chunks and run individual time series, and that's what again we call multiple time series. So in this video what I'm going to do is I'm going to talk about multiple time series and how we can do using Facebook Prophet. Now there is no rocket science to it. Now typically there are some methods that allow you to bake in individual product and then forecast it. There are like hierarchical time series and everything, but many times what works out is you predict each and every store or each and every geolocation, or depending on what is your granularity of your prediction, you calculate the time series for it and then you kind of aggregate it. Now this can be very process intensive or this can be very time intensive task. And think like within each time series, if you have a multivariate analysis and each multivariate analysis variable by itself is a time series, you have to kind of run a Monte Carlo simulation across each and every variable. So the complexity increases, and that's where like GPU computing and distributed computing comes into play. So that if you have to run against thousand stores of Walmart or like millions of zip code across the world, you can run it in a more distributed or a high performance computing way. Now in this video, what I'm going to show is I'm going to use Prophet and just give you a glimpse on how we can, what is multiple time series. I will show you some data and then I will also kind of run Prophet across the time series in a more like a looping way, but a single threaded mode, but that can be more like made multi-threaded as well. In the next video, I'll go into more like Apache Spark based computing of running time series. Okay, so let's get started. So I have two packages that I have installed. I have the download package and the Facebook Prophet package that I have already installed. And then I am importing all the required libraries over here that is required to do my time series analysis and time series modeling. So I have matplotlib to do the visualization. I have plotly express in this case, like I am going to skip that graph, but I have pandas to load the data. And then what I'm doing is I'm downloading the Beijing air quality data set from the UCI machine learning repository. So the UCI repository has this Beijing all quality data set in this particular location. I am just using the download packages installed. I am downloading it and telling it's a zip package, and then I'm telling extract in this temp and -QA location. So I have run this as well. The data will get downloaded and we will extract the data. Now, if I go and list this particular temp underscore AQ location, you can see a lot of data files. So how it is read, it is Beijing air quality data set, and each of these are weather stations. And you can see like there are multiple weather station. For each of the weather station, you have data from around 2013 to 2017. Now let's go and do some visualization of this data. So first thing what I'm doing is I'm just creating a function. What I'm going to do is I'm the data set as a date column. and time series is nothing but an ordered date column, ordered date information, right? So what I'm going to do is I'm kind of creating a function where I will feed the set of columns that are forming a date and then convert it to a date time column. The reason I'm converting it to date time column is when I want to visualize it, I can use date time as an index so that I can do a slicing of data, right? So that's why this function is there. So I'm calling the convert to date function, and I'm not going to read all the files, but I'm going to read three files. I am taking like Shui as one of the weather station, Vanlu as one of the weather station, and Gucheng as one of the weather station. And I'm creating the pandas.read CSV. And then I'm giving the past date. These are the columns that are available: year, month, day, and hour. These are four columns that form the time series for this particular data. And I'm then calling this convert to date function. This convert to date function is to take this four column and convert the output into this format: year, month, day, hour. So let me run this three. Similarly, I'm doing for each and every file. I'm taking three file out of the list and I'm doing for each and every file. And then what I'm doing is, once I have this three pandas data frame, now since I have three file, I have three separate pandas data frame. What I'm doing is I'm doing a pandas.concat of this three different frame, and then I'm assigning to a variable called aq underscore df, that is air quality underscore data frame. And let's quickly print the output and see how it looks like. So this is how it is. This is the date column: year, month, day, and hour, what we created using the convert to date function. There are a lot of values. Number is just an ascending order number. So we will drop this column. Then there are multiple other variables like PM 2.5, PM 10. These are all nothing but your air pollutant level in that each and every city, each and every station. For this particular video, we are going to focus on the temperature column and then the O3 column, which is nothing but the ozone, right? So ozone basically, what happens, it reaches like unhealthy level during the sunny days, and ozone can be caused by your vehicle or industry pollution or chemical plants or even power plants. There are multiple factors. So we want to see whether how the ozone variable behaves over time, and we are going to forecast this so that we can manage the city better, right? That's the basic idea of it. So this is how the data looks like. What I'm going to do is I'm going to first drop the number column, which is nothing but a serial number. So I'm just dropping it. I'm just calling the drop function, and now you can see the database that number column is gone. Right now, what I'm going to do is this data is at hour level. So for example, on each day you will have like multiple data every hour. So in a day there will be 24 observations. So what I'm going to do is, to just keep this video fast, I'm going to aggregate this hour level observations to day level observation. So for that, what I'm doing is I am basically calling a group by station. For each station, I have to do it because if I don't give the group by, then it will be aggregated across all the station. All three stations are a single data frame. It will like kind of do an resampling across the data frame. So what I'm doing is, here I'm telling a group by station, and I'm telling resample this data to daily. From hourly, make it daily, and every 24 hours data will be merged, and I'm telling take the mean out of it. So it will calculate mean of PM 2.5, mean of PM 10, mean of O3, mean of temperature, right? So that's what I'm doing over here. So if you see the output now, after that is done, you will have only the day level data: 0, 1, 0, 2, 0. There's no hour level data, and it is like group by station level, right? There are three stations. Because of the display, it's not showing all the three stations, but there are three stations in the data, and you can see the mean of each and every this variable is calculated at the day level, right? So that's what it is there. Now what I'm going to do is I'm just going to, now you can see the index, these two are index column and these are the column. I don't want the index column. So what I'm going to do is I'm going to reset the index so that the data becomes like complete tabular. There is no index at all, right? Now I'm going to quickly visualize the three weather station data. So what I'm doing is I am taking this data. I am like again set, because to visualize I need to put x-axis time, and the way to do it is create index. So I'm doing a set index and doing this timestamp column as that, and then I'm doing a query on station Shunhee, and then I'm taking O3 and temperature as column and plotting it. So this will only take one station. The second will take station Vanlieu. The third will take station Gucheng. Right now, if you take this data, this has data from 2013 to 2017. The orange line is temperature and the blue line is O3. You can see basically there is a increase, decrease. There is some seasonality to the data, right? And sometimes the increase is pretty high. Sometimes it's like around 150, sometimes it's 175, and in one cases it has gone above 175 as well. There's a seasonality, and the seasonality, if you see, as the temperature increases, the O3 level also increases. Basically, the O3 levels are higher during the sunny days, but it's not necessary. It can be also higher during the winter days. But in this case, it's higher during the sunny days. And as the temperature decreases, it becomes colder. The O3 level in the air, the O3 pollution level in the air also decreases. So you can see this particular pattern on this station. Similarly, let me run for other two weather station as well. Right. So now if you see the other two weather station, let me take this, the last one. So in this case, what I am doing, if you see, again it's around 150. It in the second one jumps above 175. Right. But if you see the previous one, this was still in 150, the second one. The third one jumps above 175. The previous, if you see, like the second one is 175. So all three weather station has a different pattern, right? We cannot just generalize this and just build one time series model, right? So we need to kind of build an separate time series model so that the forecasting is done accurately, and that will be in the retail sale as well. Maybe product one will go better in a summer region, in of Walmart better than a colder region, right? Similar product two. So you need to kind of forecast the exact product demand so that you can assign the raw materials and workforce to that accordingly, right? So these are the three time series data. Just a Andy function. What I did is I individually plotted it, but you can also directly like query and then just like not this function. Yeah. What I'm doing is rather than querying on the station, I'm just doing a group by station and plotting it. So once I run this one, it will give all the three plots in one command. So you don't have to run it. So if you see, all the three plots are over here, 1, 2, and 3. So that's just a handy function over there. Now again, let me check the output. Now what I'm going to do is I have three stations now, but here I'm only seeing two stations. So what I can do is I can just do a station of unique so that you can see, like, if all the three stations are there in the data frame, you have all the three stations now in the data frame. So now let's start modeling, right? So for that, first I'm doing is I'm importing the Prophet package. I'm telling from Facebook Prophet, FB Prophet, I'm importing Prophet over here. Right. And then what I'm doing is I'm creating one final data frame. I am taking only the column, the date column, the kind of ozone column, which I am going to forecast. Then I'm taking the temperature column and station column, both of this. Now, Facebook Prophet expects the data to be in a particular format. It expects the column name for the date column to be DS. That's why I'm renaming this. I'm taking this column and I'm renaming it. The date column should be DS, and the target column, which we are forecasting, which is O3 in our case, ozone, should be Y. So that's why I'm renaming these two columns, but the other two I'm leaving as it is because I'm not going to feed it to the model. But you might want to maybe later feed in temperature also and check how multivariate analysis works. I have a separate video on multivariate analysis. You can click the link on the top and watch it. But in this case, I'm going to more focus on O3 alone. The purpose of this video is show like how multi-time series can be done, right? So let me run this, and once you print the final data frame, you can see you have a column with DS, Y, temperature, and station, right? Now, the very first thing I'm going to do is I'm going to group by station and assign it to a stations variable, right? So the reason I'm doing it, I want to know all the station so that I can run multiple model. And station is how I split the data here because each station is a time series for me. So once I print the station.date, you can see the output. You have like all the three data frame, right? This is the first data frame, which has the first few columns because I have written head of it, the second station, and the third station. So I have all the three stations now. Now what I'm going to do over here is I am going to I'll skip this step because I'm going to tell that as I go into the details of it. In case if you want to like split the data frame, train, test, and run it, you can run this. But for now, like I will go to the next one and show you some of the commands will be repeated. So I am assigning an empty data frame called target. right? In this target data frame, I am going to build all the different forecasts from the different station. So I am creating an empty data frame called target over here. Okay, now next what I'm doing is I have the stations over on the top, right? The stations variable that assigned. So when I say stations dot group, it's going to give me all the stations that are available. There are currently 3 stations. So for station, I'm picking the data for each station. So I'm running a for loop over here. Now I can run it in a multi-threaded way. I can run it in a distributed way. That's all something add-on I can do later. Right. First, let's understand like what I'm doing here. So I'm taking the stations. I am iterating to each station. Then I am assigning a group variable and I'm telling get group of stations. So the group variable will have all the data for that particular station. So first time it's going to iterate to station 1 and it will have the group variable for all the station 1. That is data for all the station 1. Then I am initializing the profit model. Here I am telling create a profit model with an 95% confidence interval. By default it's 80%. I'm giving 95% confidence interval and I am fitting the data. The group has my data now for that particular station. I'm calling a model.fit. And then what I'm doing is I'm telling make future data frame for 366 days. So predict 1 hour ahead for me, right? So I have data, I have modeling it based on 2013 to 2017 data, and then I am predicting for the next 1 year. So I'm making a future data frame, and then I am just calling that model.predict future, right? Future, so it will predict for 366 days, 366 days, and then I am plotting the forecast, right? Now, then what I am doing is the forecast will have the output variable. The output variable is y at, right? So you have y at upper threshold and y at lower threshold. That is nothing but the 95% confidence interval. But in this, I'll focus on only the actual forecast, the y at variable. So I'm taking the forecast data and I am renaming the column from y at to y at underscore station. The reason I'm doing it, when it runs the second time, it's going to kind of create another forecast variable and then override it. So that's the reason I'm doing it. And then what I'm doing is in the target variable, I am, uh, I am basically setting the index as dx, and then I am going to assign the forecast to it, right? So my target will have all the forecasts that are getting developed. So whatever the forecast holds, my target will have everything in that, right? So let me run this. It's going to iterate 3 times because we have 3 stations. And let's see the output, how it perform also, because I'm doing a m dot forecast that will print the forecast. It has run for 1, it has for second station. Now it's going to run for the third station. So kind of it's running individual time series model and then it's printing the output over here, right? So if you see, this is the black points are the actual O3 levels, and the blue value over here are the predicted y at, and the light blue value is nothing but the confidence interval. So it's the top is the upper confidence interval, lower confidence interval. Most of the data points falls within the confidence interval, but they are not close to y at in some cases. But what you can do is that's why you can go for multivariate analysis and add some other features that can contribute to it, right? But let's in this case I'm just going to stick on to this graph. The if you take the confidence interval, the forecasting has been like decent. Similarly, it's for that's for station 1, this is for station 2, and this is for station 3. Now what I'm going to do is if you print the target data frame, you can see all the different variable the forecast data frame had. You had y at lower of x, y at lower of y. There are multiple things that comes in, but I'm just what I'm going to do, I'm going to kind of do an iteration of different station groups, and then I am going to only take y at underscore station. So what it is going to do is there are 3 stations. It's going to iterate to it and assign it to target variable only the 3 output. If you see over here, I have only the 3 output. Basically, my index column is the timestamp. I have the forecasted value of the station Gucheng. I have the forecasted value of the station Shunyi. I have the forecasted value of Vando. Right, these are the 3 stages. So now I have the forecast of all 3 separately. Right, so I can just quickly go and plot how it looks like. With my what I'm doing is I'm taking the actual value in the data frame. I'm just concatenating the actual value, and then I'm querying by station, and then I'm giving the target value. We already saw inbuilt graph from forecast, but if you want to do it by yourself, you can do the plot as well. As I said, this orange one is the forecasted value for the next year, and if you see, it actually recognize the seasonality of the data, right? But only thing, the peak is not recognized, which is more like we need to do more like multivariate analysis to do that. And that's about this. In the next video, what I will do, as I said, a forecasting problem for multi-time series is a very challenging problem because you need to have enormous compute. Think if you are forecasting for millions of zip code. If you don't have, if you do it like this in a single threaded way, your program itself will run for weeks or months. So you want to run it in parallel so that you have forecast in a very near future, in a few hours, or at least within a day, right? And that's why you need distributed processing, which I will cover in my next video. So that's about it. Thank you.